and the whiteboard. Now remember, this is the first derivative, the first theorem, the fundamental theorem of calculus number 1. This is the one that is kind of repetitive, but the question, the problem with the question is not the question, it's the answer. That answer is not correct. I had that verified by 2 other teachers. It's all messed up. I don't know how they got that answer, and they don't either. This is basically you're taking the derivative of an antiderivative, which is basically means that you're undoing what's already been done. Square root of x of 18t to the 9th. Okay, remember when you have this type of setup and you have the variable up here, variable is right there, then you just have to put an x in, 18x to the 9th. That's it. That's it right there. But since this is not just x, when it's just x, if it says 1 to x, or if it says 0 to x, or if it says negative 5 to x, or 8 to x, or 3 to x, or if this is just x, then you just rewrite it with an x. Because what is the derivative of x? 1. And you multiply the whole thing by 1, you get the same thing. So when this is x, you do the chain rule and you get just this. But this is not x. This is x to the what? X to the 1/2 power. So that means you've got to use the chain rule with x to the 1/2 power. And what is x to the 1/2 power? The derivative. 1/2 x to the negative 1/2. Okay, so now I've got to do my derivative. I've got to actually put it in. I got to put everything in. So I'm going to rewrite. 18 parentheses 9 brackets, and that's going to be my chain rule. And of course the x to the 1/2 goes in here. And I'm going to change this because everything's focusing on this guy right here. And everybody's going to say, well, Hubert, what about the 1? Why am I not worried about the 1? What's the derivative of a constant? I want y'all to interact with me. What's the derivative of a constant?
0.
0. So if you plug 1 into the problem and take the derivative, what are you going to get?
0.
You're going to get 0. Thank you. Is that Miss Sterling? Was that Miss Sterling or Miss Rowland? Who was that?
Sophie.
Oh, I'm sorry, Miss Wilson. I can't see unless I turn around and see the little bar. You know, I'll shut up.
Don't go thinking it's me. I suck.
Okay, I'm sorry. Oh, gosh. I had to get her into the conversation, didn't I? All right, this will be x to the 1/2, and this will be 1/2 x to the negative 1/2. Now I want you to finish, because that's all the calculus there is. All the rest is what?
Algebra.
Algebra. So finish it up, simplify it, and then I'm going to tell you what to pick on your homework, because no matter which question you get, because a couple of the calculus teachers that I talked to tried 2 other problems and they couldn't get the answer, then it's just, I think the next one is 12t to the 6th. We're going to do that one too. Now remember, this is not very important for your second calculus class. This is kind of between derivation and theory. Okay? So it's really not that important. The ones that are important are the ones that I go over and tell you are important, which we're going to go over today. they also said, I talked to them on the phone, and they're at the Pendleton campus, they said that there are several homework problems in this, and it's usually the ones that do not have a what? Help me solve this. And they have found out that they are new questions and that they are slowly integrating the new questions into the homework. Well, I put in the thing to the publisher. When it says send to publisher, I put you should not put any questions into the system until you have at least one avenue of explanation. I said, to me, that's not being very productive. What do y'all think?
It's fair.
I think that's fair, yeah. You ought to have at least one avenue of explanation. Because the book, I looked in the book, there is no question like this in the book. And I looked in, is this Sullivan? What's the name of this book? Vinegar? Pierce. Well, I know it's Pearson, but the author. I think it's Vinegar. I met him one time. Briggs. It's Briggs. Okay, it's not Vinegar. Okay, but I looked in the Sullivan book, and the Sullivan book, which we used last semester, didn't have this type of question in it. So I don't know. So I'm going to do this for everybody. I'm going to put an 18 over 1. And I'm going to put x to the 1/2 raised to the 9th power over 1. And then 1 over 2. And then x to the negative 1/2 over 1. Now the reason I'm doing that is so y'all don't screw it up, because some of y'all can break an anvil with a banana. So I'm going to show you how not to screw this up. So that's going to be 18 divided by 2. What's 18 divided by 2? 9. So 9. And then it looks like x to the what? 9/2? Sorry. I don't like to write in red. X to the 9/2 times x to the what? And then add the exponents, you get 9x to the what? And that's your answer. Now, even if you look at those answers, none of those answers make any sense. I know 3 of them aren't supposed to make any sense, but that 4th one don't make any sense whatsoever. So, what do you do on this homework question? You pick the one that has the exponent out to the side right here. Right there. See it? That's what you pick. It's the wrong answer. And they have sent it to the publisher, and I have sent it to the publisher. As far as I know, it's wrong. Because I've done it several different ways, and I can't get anything but 9x to the 4th. Now, the other question is, I think, 12x to the 6th, I think. Let me pull it up. Just so you'll have 2 in your notebook. And like I said, these are not that important. But for your homework, let's see, that's number 22. There it is. Miss Iabi sent this one. Yeah, 12t to the 5th. Okay, you do that one. And you should be able to knock it out without any problem. First of all, make the square root of x to the 1/2 power. Rewrite it. I'm going to put x to the 1/2 power here. And then 1/2 x to the negative 1/2 there. All right, finish it. And that's going to give you a 12 over 1, x to the 5 halves over 1, 1 over 2, x to the negative 1/2 over 1. And that 2 will cancel that 12 out to 6. And that'll be x to the 4 halves, which is x to the 2nd. So your answer is 6x squared. Or did I do something wrong? 5 minus 1 is 4. Okay, I came up, it's not, they got a 4 there. I don't know why they keep, just pick D. I don't know. Make sure I didn't mess up anything. 5 halves. 5 halves minus 1/2 is 4 halves. 4 halves is 2, so. And that's that. Again, do not worry about this on the test because I'm not going to put any of these on the test. Questions I'm going to put on the test are the ones like we're going to do today and the ones that we did yesterday. And I'm going to put one here on here in just a second. So the reason I accidentally put these on the homework, and I'm sorry, I didn't know they were the theorem, the first theorem, which is undoing a derivative. So they're not. You can not know these, and you'll be fine in second calc. And I know you think I'm crazy, but you don't need it. All right, so let me get to the whiteboard, and I'll throw some problems up. Here's a test problem. The antiderivative. Okay, this one's kind of easy, but we'll do it anyway. The antiderivative of 12x squared 4x to the 3rd minus 8 to the 5th power dx. Okay, so find a u. I would make u equal to what's in the parentheses. And I'm going to rewrite this because I want to put this number right here, I want to put over here. So I'm going to rewrite this and say 4x to the 3rd minus 8, parentheses, to the 5th power, 12x squared dx. So u is equal to 4x cubed minus 8. du is equal to what? 12x squared dx. Do we have 12x squared dx? Yes. So basically, we have this integral in the form of u to the 5th, what? du. So all we've got to do is the power rule. We don't have to add anything to this one. And yes, I will give you some that you don't have to add. I will give you some that you do have to add. So what is the antiderivative of u to the 5th? U to the 6th over what? 6. Resubstitute, parentheses, to the 6th power over 6, and replug in 4x cubed minus 8. Plus what? Plus c. Because this is not a definite integral. It is an indefinite integral. Comprende?
Comprende.
Now on a scale from 1 to 10, that's about a 2. A 1 or a 2. So you should be able to do that one. All right, now here's a trig. So y'all know what to do on these. Just what? Quit. There you go. Just quit. Antiderivative. Cosine of t times e to the sine of t dt. And I would probably use this for your u. And I'm going to rewrite this because if I'm going to make the e to the whatever part of the u, I'm going to write this with that dt. So e to the sine of t. And this is just something I used to do as a student. I would go ahead and rewrite to see what I needed to add or not. So I would put that, whatever is not used as u, I would put that over here beside this dt. So u is equal to the sine of dt, sine of t. What is du? What's the derivative of the sine?
Cosine.
So we have the cosine t dt. We have cosine dt. So what do we have? We have the antiderivative of e to the u du. Well, the derivative or the antiderivative of e to the u is e to the u. Remember me telling you that? E to the x is e to the x. Now, the only time something is different is when you have e to the 2u or e to the 2 sine t. Then you got something different, all right? Or e to the sine 2t. You've got something different. But this derivative is e to the u, so that's going to be e to the u plus c, which is equal to, now, some teachers don't mind this, but some will tell you to back substitute. Okay, and in that case, it would be e to the sine t plus c. I feel like we've done these. No, I know we have. Have we done? We did that. Okay, here's one. Yeah, this will make you quit. I know we haven't done this one. Cotangent squared x times cosecant squared x dx. Now, you really the lesser of two evils, but I would make u equal to the cotangent of x. Okay? And this is where you need to know your derivatives. Okay? U is equal to the cotangent of x. Okay, you need to make a note here. You need to know your derivatives on this one, because what is the derivative of the cotangent of x? Cosecant squared x. And if you don't know that, then you're not going to know what to make u equal. Because what do we have? We have the cosecant of dx, cosecant of the square root of x. So you have to know, okay, well, if I make u equal to the cotangent of x, then that's part of this one, because this is cotangent x squared is what that is. Let me fix that. That looks kind of funky. Let's see. There we go. That's the same thing as cotangent x squared. Okay? If I didn't know my derivatives, I would be like, well, I don't know what to pick. So if you're sitting there going, I don't know, how do you know to pick that? You know you've got your derivatives on a card somewhere, looking at them and say, well, if I pick cosecant squared, I don't even think I have a cosecant squared derivative. But I do have a cotangent squared derivative. I do have a cotangent derivative. So the du is equal to negative cosecant squared x dx. And look what we have. We have positive cosecant x dx. So we need to add a what here? A negative there, and we need to add a what? A negative there. because negative 1 times negative 1 is positive 1. So now we have negative 1, or negative, you don't have to, antiderivative of u squared du. There's du. And this is u squared. I'm going to just kind of do this right here. And that is, there you go. And now you just do negative u to the third over 3 plus c, which that turns into cotangent to the third, negative cotangent 3x over 3 plus c. Okay, this is a good one. I like this next one. I don't think we did it. We may have, I don't know. Did we do the antiderivative of x times the square root of x minus 1? I don't think we did. On a scale from 1 to 10, this is about a 6 or a 7 because you have to know. You don't have to know them by heart, but you have to have a card with them to see the relationship between the cotangent and the cosecant squared. Because if you just don't know it or you don't have a card sitting beside you, you stare at this one for 15 minutes. Or you do what? You skip it. Of course, y'all don't do that, do you? No. Okay, here you go. Antiderivative. I'm going to let y'all do this one. I'm not going to give you any hints. X times the square root of x minus 1 dx. Now, first of all, which would you think? What do you think would be your u? I'm asking you to be interactive with me.
Square root.
X minus 1.
X minus 1, good. And those that say the square root, you're thinking right, but you don't want to include the square root into, because that's going to be x minus 1 to the 1/2 power. Okay? Remember, radicals and calculus don't what? Don't mix. So rewrite it. So your x minus 1 is going to be your u. Now put a star beside this one, because you're gonna have a problem with this one, and it will cause you to quit the problem. Throw your pencil down, make it pop on your notebook paper, which usually precedes slamming your book down or pushing the desk away and then eventually kicking the cat. Y'all gonna miss me next semester.
You don't gotta tell me that.
You're gonna miss me because you're gonna have some teacher that talks about math 180% of the time. Some of y'all might be happy, I don't know. So I'm gonna rewrite mine. Antiderivative of x times x minus 1 to the 1/2 power. And I'm gonna make my u equal to x minus 1. Is Mr. Swords there? That's who I didn't call in. Is he at the Easley campus?
He is not.
I knew I forgot somebody. I intentionally left him out because I really don't like him. Y'all don't tell him that. No, I don't tell him. If I tell him not to tell, that's exactly what he'll do. There we go. He probably like, damn. Okay, so what is du?
One.
Du is equal to 1 dx. Y'all got to remember to put the 1 dx, because that gives you a hint what you need to do. du is equal to 1 dx. We don't need 1 dx. We need what? We need x dx, because if I rewrite this, we need what? We need x dx. Then what should we do? We ain't got it, so what do we do? Quit? Yeah, quit. We don't have an x. How do you make a 1 into an x? Well, that's when, and this is important for second calc. I'm going to put this in red, and you know I don't like red. You're going to go up here, right here, you're going to say, we need an x. Okay, that's what you're going to say. We need an x. Uh-oh, we can't make a 1 out of, we can multiply by x, but that's not going to help us. So what do? Well, we go up here and we solve for x. Remember me mentioning that to y'all a couple of days ago? Now this is something you need to put a tab on your notebook and say, we'll see in second calc. So I'm going to solve this for x. U plus 1 is equal to x. So now I can take that u plus 1 and I can plug it into here. And then this is u to the 1/2. So now I'm going to have the antiderivative, and I'm going to write this in red because we're using that. Okay? U plus 1 put that in parentheses, times u to the 1/2 power. Now, take a minute, take a second, or take a minute, and make sure you understand what I did. Okay? What did we say x was equal to? I wish I could, if I could have this thing hooked up to my head to where it could read my mind on what to pick, I'd be a millionaire. Okay? X is equal to what? U plus 1. So since I could not manipulate the problem to give me x dx, I solved for x and put in u plus 1. Now, distribute that u to the 1/2. Now it's algebra. And I forgot my du too. That's du. Forgot that. Now, there's some of you that are saying to yourself, okay, I see what he's doing. Okay, good. There's some of you that are saying, I don't know what the hell he's doing. Okay? Those of you that are saying, I don't know what the hell he's doing, you need to pay attention to what I'm doing because you're going to have trouble in second calc. Okay? You need to understand that at this point right here, and I'm going to put this in blue. At this point right here, we have been saying that I need a 2 dx, or I need a 1/2 dx, or I need a natural log of x dx. Okay? Something that we could actually what? We could put out here 1 over. Okay? But sometimes you can't make an x appear out of a 1. Okay? You can't do it because you don't know what x is. So what do? Well, that's when, if you have an x here and you have a constant here, then you're going to have to solve right here, you're going to have to use plan B. And that's when you have to solve for x. So when you distribute that u to the 1/2, what do you get? Well, you get the u to the 1/2 times u to the 2/2 plus u to the 1/2 du. I'm going to make this small so I'll have more room. Now on a scale from 1 to 10, we're at about an 8, okay? And you need to make sure you do a couple of these in the homework on 5.5. So now I've got the antiderivative of u to the what? 3/2 plus u to the 1/2 du. Now you can take the derivative of the two terms. The antiderivative of the two terms. So go ahead and do that. Oh God, I forgot y'all can't do that because it's what? It's fractions. Y'all can't do that. Oh well. Maybe one or two of y'all can do it. Miss Sterling, can I depend on you?
Have you ever?
Miss Sterling, I tell you, you're just a ball of optimism. So, here we go. But I do appreciate you interacting, so you will be successful in life. You're not going to be winged on a pickle the rest of your life. So, that's going to be u to the 3/2 plus 2/2 over 3/2 plus 2/2. Y'all quit yet? Plus u to the 1/2 plus 2/2 over 1/2 plus 2/2. All right, now I'm going to get y'all to finish it with all of your algebra expertise and back substitution. Because I have confidence in y'all. Miss Gusmus, I have confidence in you. I love y'all's optimism. It's like, yeah, right, whatever. Mr. Swords, I do not have confidence in you.
That sounds about right.
That's all right. Bernie's going to take care of all y'all.
Yeah.
He's going to make sure y'all have $15 an hour, but he's going to cut your hours. I bet those people felt like taking a bat to him. Yeah, man, we're going to give y'all $15 an hour. And they all jumped up and down. And then he said, but we're going to cut your hours in half. I'm sorry. That's funny. Don't do as I do it. Let's see. What is the old saying? Do as I say, not as I what? Do. Yeah.
Do.
In other words, like most of I ain't gonna say what they are, but most of them, they want everybody to do this. Want everybody to cut back on their carbon footprint, but they take a private jet over to Europe 2 or 3 times a year. Or like Leonardo DiCaprio, 16 times a year. But we got to stop. What is it? Global warming and climate change? We got to stop it. Miss Sterling, how many times did you take your jet over to Europe this year?
I can't come up with snark fast enough to answer that.
Oh, man. Last day of class, I'm losing y'all. Okay, so that's going to be u to the 5/2 over 5/2 plus u to the 3/2 over 3/2, 2/5 u to the 5/2 plus 2/3 u to the 3/2. What is u? X minus 1, right? 2/5 x minus 1 to the 5/2 plus 2/3 x minus 1 to the 3/2, or 2/5 exponent over index, the square root of x minus 1 to the 5th power. You can reduce this, but I'm not going to, plus 2/3 exponent over index. Exponent is 3, so that's going to be the square root of the 3rd power. The square root of x minus 1 to the 3rd power. And you can see that there is more that you can do with this, whether it's, taking the square root of the 5th, that's going to be x minus 1. You can take the square root, that's going to be x minus 1 to the 2nd power times the square root of x minus 1 plus 2/3 x minus 1 times the square root of x minus 1. So there's several different avenues you can go from there, but that's the setup, that's the answer there. Well, make sure you make a note of that one, because that one will get you.
I should have told you that
these. Say again?
I should have told you my private jet was in the shop, but considering they're now getting paid $15 an hour, I don't know when I'll get it back.
Yeah, Bernie gonna take care of y'all. And Kamala Harris, she's gonna give everything away. She's promising everything. So, and I really don't think Joe Biden knows what state he's in, much less what date it is. So I don't think he really knows what's going on. All right, let's do a nerding. Let's look at the homework. Let's pull up your handy dandy homework. Well, I did have it pulled up. I guess it's gone. So tctc.plus.com. And it should be your last homework. Assignments. There's only like 12 problems, so y'all can't bitch about that. Somebody will. All right, try that one. It's not a hard one. I don't know why I said that. It's not a difficult one, but just change the pace. That's a spicy meat bun. Of course, this class don't laugh. It doesn't have a sense of humor, so I don't know why I'm laughing. Did I ever tell y'all why I didn't finish civil engineering?
They wouldn't talk to you?
That's it. That's why I quit going. I hated going to the classes. You'd walk into the class and I'd say, "Good morning," and everybody just sit there and look at me. I hated it. And I would say probably 3/4 of those people are working in a closet. Yeah, they're making a lot of money, but they're working in a closet. Nobody talks to them. So I'm going to rewrite this, and I'm going to say x squared plus 13 to the 12th power 2x dx. Now again, that's something that I do. You is equal to x squared plus 13 du is equal to 2x dx. Do we have 2x dx? Yes, we do. So we don't have to add anything. All we have to do is rewrite it and say this is the antiderivative of u to the 12th du. And now take the antiderivative. That's going to be u to the 13th over what? 13 and plus c, and then plug in x squared plus 13. So that's going to be x squared plus 13 to the 13th power, that was just coincidence, over 13 plus c. And I'll give you several of those on the test because I'm not trying to fail you. That's not what I'm trying to do. I'm trying to get you to learn these basics because you're going to see the basic fundamental theorem. This is the second fundamental theorem of calculus. The first one you really don't. It's just 2x, x squared, 2x. You don't have to do that. The second theorem of calculus is the basics, and then substitution is the second basic. That way you get to move into integration by parts, which is ultraviolet minus voodoo. And I'm just going to punch a 3 in here just so you can see that I do somewhat know what I'm doing when the answers are not wrong. Okay? One 13th, which is 13 on the bottom, x plus c. Don't forget the plus c, because I don't know if this one puts the plus c or not. I know WebAssign does. That's what we used to do, and it sucked. All right, let's try another. I'd like to get a definite integral before we quit today. Let's see. Let's see if I can get a definite. That's an easy one. Yeah, that's pretty simple. What's that one? What's that one? Is that 6, 8? All right, try that one. It's not a definite, but somebody sent. You sent one. Your question was a good. Okay, we'll go over yours next. I'll need to hurry up with this one because you sent a good test question. I forgot yours. Even though it's not substitution, I think it came from 5.3. All right, antiderivative. Yeah, but it's a definite. And you don't, I'm just going to write 8x plus 4 to the 1/2 power dx. And then u is equal to 8x. Therefore, du is equal to 8 what? Dx. So what do we have? We have dx. We ain't got no what? I'm sorry. We don't have an 8. Or we ain't got no 8. So we got to put an 8 here. And if we put an 8 here, and this will go crazy. It didn't go crazy. If we put an 8 here, what do we got to put out front? A 1/8, Hubert. Thank you, class. There it goes. Mr. Swords, I need training.
I'm surprised they never did give any, but you know how it goes.
Boards for 3 years.
I'm so shocked.
And the IT can't understand why at Pendleton campus the teachers don't use them. Which came first, chicken or the egg?
Well, after hearing you talk about that, I was determined if we ever get a full campus of new equipment, I'm gonna make sure I train everybody here.
Well, you know what? The person has to be trained. And see, people in IT, there's people that come in here when I ask them to come in, they don't know what they're doing. They don't have any idea.
Yeah, no, that's true.
So that people wonder why I call it Mayberry campus. when I have to tell the IT people how to turn on this thing and how to work this thing, that's sad. So we get 1/8 antiderivative of u to the 1/2 du, because this is du, and this is u to the 1/2 power. So that's going to give us 1/8 brackets. I'm going to do this because I don't want you to break an anvil with a banana. U to the what? 1/2 plus 2/2 over 1/2 plus 2/2. One-8 u to the 3/2 over 3/2. And multiply this by 2/3. And we've got, what does that come out to be? 1/12? Somebody help me out there. 1/12 u to the 3/2. And what is u? U is what? 8x plus what? Plus 4. So we just erase that u and put in 8x plus 4 to the 3/2. Plus what? See. That's a 3 or a 4. Not a big deal. That one I would practice a good bit, because that one, if it's got a radical on it or a negative exponent or something like that, I'm going to pick it, because you're going to see that. Let me jump back to the homework right quick, because I only got like a few minutes and y'all start convulsing. So let me go right quick and go to the homework again. I forgot to pull this. And this is a good one from, from 5.3. This is a test question from 5.3, because why would I pick it? Well, I'm going to show you why I would pick it. 2 reasons. It's a definite integral, and why would I pick this one? Somebody want to take a stab at why I would pick it besides it's a definite integral? I love the interaction in this class. I just love it.
I have no clue why we picked this one.
Oh, come on.
It's not simple. You'd have to use product rule or something.
You got to use product rule, but what do you got to use 80% in calculus?
You have to use algebra to get into one polynomial.
There you go. You've got to use algebra. You've got to use algebra to get it in a form that you can actually take the antiderivative of. Because remember, how many rules do you know right now of the antiderivative?
I'm going to say 2 because you have to figure it out.
The basic power rule, which I showed you, and substitution. So right now, in the first part of calculus, second calculus, when they give you an antiderivative, it's either going to be a basic power rule, it's going to be substitution, or it's going to be use algebra before you even start. So the first thing I would do is turn this thing around to where it looks like something you recognize, because nobody writes an algebraic equation 1 minus x. I don't know where they get these people to write this stuff, but negative x plus 1 times x minus 4. So what are you going to use? Your FOIL method. Say it however you would like. FOIL method. So get to it. Miss Sterling, what time is class over?
4:25.
Okay, we got 10 minutes. Now, if you can do this problem, you can handle 5.3 material. If you do this problem with me and you know how to do it and you're fluent, you're good with 5.3 on the test, because it's got algebra, It's got the power rule, it's got definite integral, and it's got basic math and plugging and chugging. So it's got everything in it. Kill dang old two birds, dang old one stone. Dang old rock.
Are you teaching 141 in the fall?
This is the math department's theory. They believe that everything above math 140 should be taught at the Pendleton campus.
That's a great excuse for one of the calculus professors to still have a job.
You nailed it right there.
Kind of sucks when everyone bails this class.
Yep. Say that one more time so everybody could hear you. It's called guarantee of a job. Don't worry, I've got some second calc videos on my YouTube somewhere, and y'all are welcome to send me a question. If you need some help, I'll be glad to help you out. Just do it by Skype. Please don't try to come by here, because my schedule is in the fall is like a ping pong ball in a mousetrap room. I mean, it's just all over the place. So just try to Skype me or whatever, and I'll be glad to help you out. But give me at least a few hours to look at the problem so I can, associate myself with what part of the chapter you're in and all that good stuff. Be glad to help y'all. And it does call for you to, communicate. For some of y'all might as well go ahead and drop it because y'all can't communicate. But some of y'all can communicate. Send me an email or send me a text. I'll be glad to help you out. Yes, Hubert. Okay, Hubert. Thanks, Hubert. You're welcome. Negative x squared. Y'all suck. Negative be a positive 4x plus 1x minus what? Can we combine anything? Yes. Negative x squared plus 5x minus 4 dx. Now you're ready for some calculus. So that's going to be negative x to the third divided by 3 plus 5x squared divided by 2 minus 4x evaluated at 1 and 4. So I'm going to go back to Hubert's methods when he was a student that I use today, and I've got 3 degrees, and I still use it, but there's people that don't need it. But anyway, over 3 plus 5 parentheses squared over 2 minus 4 times parentheses minus brackets, same thing. Oops, that's not supposed to be an X. Sorry. And that's going to be negative parentheses cubed over 3 plus 5 parentheses squared over 2 minus 4 times parentheses. And that's going to be a 1, a 1, a 1, 4, 4, 4. I wish this thing quit drawing all over the place. Oh, damn Russians. So 64 over 3. Somebody check my math because I get crazy with these multiples. That'd be a negative. 64 over 3. Okay, 4, 6, 80. Somebody help me out. 80 over 2. 16 times 5, I think. Minus 16 over 1. Yes, I'm making fractions out of everything. Why? Because I'm going to have to get a what? Common denominator, because I don't want to depend on the idiot box, because then I won't be able to spell mom backwards when somebody asks me to think. Negative 1/3 plus 5 over 2 minus 4 over 1. Please check me and make sure I haven't messed up somewhere. So now I got to get a common denominator of 6. So that's going to be negative 6 plus 6 minus 6 brackets minus brackets 6, 6, 6. Going to hell in a handbasket. Negative, positive, negative. All right, 3 will go into 6 2 times. 2 times 64 is 128. 2 will go into 6 3 times. 3 times 80 is 240. 6 will go into 1 6 times. 6 times 16, 96. 3 will go into 6, 2. 2 times 1 is 2. 2 will go into 6 3 times 15. And 1 will go into 6, 24. All right, now, check me. And hurry up, because somebody's going to start convulsing if we don't hurry up. Did I change all of them right? In other words, 3 times 64, check it, make sure it's 128. Or whatever, 2 times 64. Okay. Oh. Negative 128 plus 240. Somebody give me that. I have no idea what that is. I suck at subtraction. What is it?
112.
112. So that would be 112 minus 96 over 6 minus, and I'm just doing step by step, negative 2 plus 15 is 13. 13 minus 24, negative 11. Somebody help me out. And 112 minus 100 is 12, plus 4 is 16. So that's going to be 16 over 6. Somebody help me out.
Yeah. That's
Plus
right.
11 over 6. I got 27 over 6. Now, do you want to know if you're good for the chapter, for the 7.1 or my 5.3 test? If you can do 2 or 3 of these problems, hit similar question, if you can do 2 or 3 of these and get it right each time, you're good for 5.3. So let's check and see. God, I hope I got it right. If I don't, then we're quitting. 27 over 3 or 6? It's a miracle. So that's a good question. You did good sending that one, Ms. Rudy. Okay. So, y'all have, I'm going to put 2 tests up in the next day or 2, and that will be your Unit 3 test or Unit 4 test. We skipped Unit 3, so don't worry about it. And your final exam. Get those done by what day?
Friday?
Friday. At what time? Midnight.
7:59.
Okay, do not wait until 10 o'clock Friday night, because I will be able to see when you take the test for the first, second, and third time. So don't, if you call me Friday night, I'm going to be passed out probably. I'm not going to answer you. I'm kidding. What?
Hubert, do you think you can upload them both by like tomorrow?
Yeah.
I second that.
I'm off work.
I don't really like either one of y'all, so I probably won't do that. Yeah, I
You
can
hate
try.
it
I'm
anyway.
going to try to load
It's
them
just-
in the morning.
That'll
Yeah,
work.
that'd be awesome because I'm going to Charleston and the house that we're staying at is on an island. And
Oh, my
there's
kids
no-
are down there right now.
Yeah.
I don't
I'm
like
off
the
work,
Atlantic Ocean.
I actually
I
do.
like to see, if if Jaws is going to chomp, chomp, chomp on me, I like to see it when it's coming. So I got to go down to the Gulf. You can't see Jack. You could get eaten by a turtle in the Atlantic Ocean. You'll nobody even know it until you're dead. I mean, I don't like
nice-
the Atlantic Ocean. Plus,
Nice muddy brown water.
do you know how many shark attacks happen in the swimming pool?
Depends on what you define a shark as.
No. Oh, wait,
Depends how many dumbasses
I
put a
don't
shark in
mind
the
those either. But anyway, none. That's why Hubie and his cooler hang by the pool. I think sharks are beautiful, but they're in the ocean and they are the apex predator of the ocean, so I leave them the hell alone. I'm not stupid. I'm not one of these, yeah, dude, I got half eaten by a shark in 1988. I've been going back and surfing ever since.
You just got punched in the nose.
Yeah, you just got punched in the nose. Yeah, say that when your ass is eating. All right, anybody got questions? Now, let me ask y'all a question. Did y'all learn anything?
Yeah.
Yeah.
Yeah, definitely.
Y'all learned that people suck at calculus because they don't know how to do what?
Algebra.
And some of y'all still suck at algebra, but you don't want to say anything.
I'll say it.
Y'all
I
get
don't
out of
care.
here and have a good break. I'll try to load those up. It'll probably be in the morning.
All right, thank you.
Y'all
Thanks,
be
Hubert.
good. Look for
Have a
me
good rest of
next
your summer.
semester. Take some more math classes.